live, I think. Come on, there we go, live. Okay, 1, 22, 21. Wow, look at that. These weird numbers. Is that a palindrome? That is a palindrome. Look at that. 1, 2, 2, 2, 1, 1, 2, 2, 2, 1. That is a palindrome. There, you just learned something, huh? Palindrome is either a word or a number that says the same thing. Holes. You guys remember the movie Holes? Stanley Yelnats. Do you remember Stanley Yelnats? And if you read his name backwards, it's also Stanley Yelnats. If you ever watch the movie again, they show that his name is a palindrome in the movie Holes. Anyway, I'm wasting time. Let's go ahead and talk about it. So today what we're going to talk about is systems of equations with two variables. Okay? So kind of a fancy word. And I like to use the math word so that if you ever see it in a math book and I'm not around, you'll know what it means. Okay? So systems of equations basically means two or more graphs. Okay? Two or more graphs. Okay? Together. And then with two variables, that's just the x and the y, right? And so our goal is to find out how they intersect, okay? How they intersect, okay? So if I take a look at example 1, I'm just going to graph example 1, and I'm going to graph example 2, and then we'll find out where they intersect, okay? So hold on, I'm going to grab some different colors. Oh, how about blue? Blue and green. That sounds perfect. So, first graph, I'm going to put, let's see, I'll put the first graph in blue. How's that sound? So I'll start at 5. 1, 2, 3, 4, 5. I'm going to go down 2 over 1 because the slope is -2 down, 2 over 1, right? And then I'll graph that line. Okay, that's pretty easy, right? Thumbs up, everybody. That's pretty easy. Yep. Let's graph the second one. I'm going to graph it in green because I like the different colors. So I'm going to start at -1. Has a slope. It's just invisible. 1 over 1, right? So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1, okay? So this is not the answer. It's just a graph that finds the answer. And the answer is there. That's the answer. The answer is the point. That's my answer, is where they intersect. So my answer is the point at 2, 1. Not bad. That's not bad at all, okay? I like that. There's my answer. Good. All right, number 2. Now, on number 2, we have to graph this. So there's two ways. One is to solve for y and graph it, okay? So I got equation 1, which is my 2x minus my 3y equals 3, okay? So to graph it, I need it to say y equals, right? So equation 1, I need to solve for y. Okay, so if I solve for y, then it's easy to graph, right? All right, I need to get the y by itself. So I'm going to get rid of the 2x, right? So I'm going to go ahead and bring the 2x over. So I'll go minus 2x on both sides. So I have a -3y because the 2x is gone equals, and you cannot subtract these because that's an x, and that's a number. 3 minus 2x, right? And then I'm going to divide by -3 to get y by itself. Everything, okay? How am I doing? Francisco, if I get going too fast, will you please tell me to slow down? Okay, I mean, because I'm here for you, not for me, right? Okay, and I get y equals a -1 plus 2/3 x, plus because the negative divided by negative. So I can graph this first one. I can start at -1, up 1, 2 over 1, 2, 3, up 1, 2 over 1, 2, 3. Okay, and draw that in. Second graph, okay, so let me go ahead and equation 2. Okay, here's equation 2. I've got to graph this one also. X plus 2y equals 5, right? And again, let's solve for y. So I'm going to solve for y, so I need to get the y by itself, so I'll go minus my x, and I'll have a 2y equals, well, you can't really subtract these because that's an x and that's not, so we'll have a 5 minus an x. I'm going to put a 1 there just so it's going to help me later, 1x, right? It really will help me. Divide by 2 everything, okay? So then we get a y equals a 2.5 minus a 1/2 x, okay? So now we're starting to get into these decimals, right? But I can do it. 2.5 is about there. I got to be careful. I have to estimate 2.5. So I'm going to estimate 2.5 right about there. I'm going to go down 1. Okay, so I'll go down 1. It puts me right about there. And over 1, 2. I'm going to go down 1 and go over 1, 2. And then I'm going to graph it in, okay? Now, here's the hard part. The best I can do right now is guess. So I think they intersect here. And it's just a guess, right? So my guess is I think it is at 1, 2, maybe 3.5. And then up maybe -1. I'm not sure. But that's a guess. So graphing, so the point I want to make is that graphing is effective only if it's nice graphs to get the answer. But if it's kind of like in between on the graph, I don't know if this answer is exactly right. I mean, this could be a 3.6, could be a 3.4, right? This could be a -1.1. I don't know, right? But if I need the exact answer, graphing's not going to do it. So there's got to be a way to do it. So let's turn the page and see what we get. So turn the page. Let's do this differently, okay? So what we could do is instead of graphing it, we can do it by a thing called elimination. Now the first one's a pretty easy elimination. I don't know if you guys remember this. You guys remember this from geometry at all? Do you remember doing this by geometry at all? Okay, well, that's right. Last year was kind of like a lost year, right? So elimination means this. I'm going to eliminate either the x's or the y's. I'm going to eliminate either the x's or y's. So if I can eliminate the x's or y's, then what would be left is the other variable, and I can solve it, okay? So this one I did on purpose because it's really easy. So I started with a really easy one, okay? I got equation 1, equation 2. And if I were to add straight down, I picked a really easy one. Hopefully you see why this is easy. Does anybody see why this is such an easy problem? What do you see? Vanessa, what do you see? Yeah, it's an easy question. I made it on purpose, so if I add straight down, these would cancel. Does that make sense, everybody? They would just cancel out by elimination. So I get a 3x equals 6. Divide by 3, and x equals 2. So now we're looking for a point, right? We're looking for a point. So what I have is I have half the answer. So my answer, and every answer is some x, y. What I have is 2 something. Okay, I've got the x is 2, but I don't have the whole answer. I've only got part of the point. I've got 2 something, okay? So I need to find its corresponding y value. So what I'm going to do is plug the 2, because this x equals 2, either in. I'm going to plug it back in. I'm going to plug it back in either x here, put the 2 here, or here. It does not matter. Francisco, what do you like? Do you like equation 1 or equation 2? It does not matter. Which one do you like? We're going to put x either, we're going to put 2 here or here. Which one do you like? Okay, we're going to put in equation 1. So I'm going to rewrite 2x plus y equals 5, and let's plug it in for x. So I'm going to put it right there, okay? So I'm going to rewrite this as a 2 times 2, because the x value is 2 plus y equals 5, okay? So instead of x, I replaced x with what x is equal to, and I plugged the 2 in for x. So instead of x is 2, so 2 times 2 is 4, right? Plus y equals 5. And now I can solve for y. Minus 4, and I get y equals 1. So that's my answer. I put the 1 over there for y. That's my answer. So I didn't have to graph these lines. I don't even know what they look like, but I do know, no matter where they are, that they intersect at the point 2, 1, okay? All right. Now, example 4 is a little bit different, because what I want to do in example 4 is I want to eliminate. So if I were to add straight down, does not cancel, right? Does not cancel. So what I do is I'm going to multiply. So I'm looking at this, and this is super important you guys see this. It's not hard. So think about this. Right here, if that was a negative 2, that was a negative 2, it canceled, right? You have to agree with that? So I'm going to make this a negative 2x by multiplying this entire equation by negative 2. And then I would cancel that. So I'm going to go ahead and add. I'm going to multiply this one by negative 2. Because I want to make them so they'll cancel. I want to multiply by something that'll make them cancel. And then I'm going to rewrite it, okay? So now I'm going to rewrite. Equation 1 I'm going to keep the way it is, because it has the 2x. And then equation 2, I'm going to make equation 2 become a negative 2x. And I'm going to make it a negative 4y equals a negative 10. So you have to multiply all the way through. Otherwise, you would change the problem. Okay. And now we can eliminate, right? Now I can eliminate. So I'm going to add the two equations, and we're going to get those cancel, right? Those are gone. I get a negative 7y equals negative 7. And then solving for y is easy. Right? Divide by negative 7, and y equals 1. So my answer is something 1. Okay? All right, Edie, we need to find the x. You get to pick. It does not matter. So I'm going to put the 1 either into equation 1 right there, or I'll put the 1 right there. It does not matter. Which one? Do you like equation 1 or equation 2? Yeah, 2 looks easier, doesn't it? Again, it doesn't matter, but pick the easier one. So if Edie picks 2, I'm going to rewrite equation 2, which is my x plus 2y equals 5. And we're going to put the 1 in for y. So I'm going to rewrite this as x plus 2, not what? Not y, but 1, because y is equal to 1. Okay. And then I'll get x pretty easily. X plus 2 equals 5, right? Minus 2, x is 3. Oop, there's my answer, okay? So again, we have 2 lines. We could graph them, and we can get the answer, but it's so much easier. I think it's easier just to do the algebra. Okay, now last thing I'll do is, you guys have your journals with you? So I want you to open your books to page 39, okay? Go to page 39. And if you go to page 39, I've already graphed these, okay? So I did these for you, okay? So sometimes weird things happen. So on A, I already graphed it. They both look like this, right? Graph 1, graph 2 are the same line. So the question is, where do they intersect? Everywhere, right? So we'd say, how many solutions do they have? Many solutions. They intersect everywhere. So how many answers do they have? A lot, right? Number B, I already graphed them. Okay, here they are. Okay, look at B. They're parallel, right? So where do they intersect? But they don't, right? So we're going to say no solutions. And then C is what we have been doing. They do intersect at a single point, and that's okay. Okay? How's that? Now, one of the things you can do is if you don't graph it, check this out. If you were to multiply this one by 2, everything cancels out. Can you see that? Multiply this by 2. And if everything cancels out, it has to be the same line because you're subtracting something from itself, right? On this one, if you multiply this by 2, you get all of these to cancel out, but you get some weird answer, okay? And this one, obviously, you can miss out. Okay, thumbs up on that one, you guys? Okay, so now I'm going to stop my recording. Please make sure I always do this, you guys. And